All right, and we're back. This is section 7.7. Again, we've got section 7.7, 7.8, and then we're going to test next week. Okay? So we got two more sections to learn, 7.7, 7.8, and then we're going to test overall chapter 7 next week.
Are we going to have it review day?
Yes. So so tomorrow we're doing section 7.8. On Monday is our review day, where you can just work on the review in class. You can ask questions. Tuesday we will go over that review. Next Wednesday is a late start day. We will have part 1 of our test on that late start day, part 2 of the test on the Thursday. Okay. I think I've explained the test already. What's that? It's like a day and a half test. So it works out that it's on a late start, like it falls one of the days of a late start day. It's all right. We'll do the no calculator portion on the late start day, and then the calculator portion on the Thursday. All right. So transforming exponential and logarithmic functions. Hey guys, we've done this, right? We have done transformations. Like, look at this whole first slide. We know, and let me get it all on one page here. Look at that middle column. We've seen all that before, right? Okay. Here's what I would say if you wanted to take notes over this. Take notes on whatever you don't remember. Like, just remind yourself of certain things. Okay. Let me go through them just so it refreshes our memory a little bit. Because again, we've done this for every single function that we've learned thus far. So vertical translation, that's moving up and down, right? That's an f of x plus k. That rule is the same rule that we learned at the very beginning of the year. Now, how does it apply to exponentials and logarithmics? Well, remember that it's outside the function, right? It's happening outside the function. So it's either going to happen outside of the exponent or outside of the logarithm, okay? Adding or subtracting outside of the exponent or outside of the logarithm. That's why it's 2 to the x plus 3. Hi. Thank you. We have an interview for you.
I'm nervous.
You'll be all right. So adding or subtracting outside is a vertical shift, up or down, depending on it's a plus or minus. Horizontal translation, that's a moving left or right, correct? So that means it's happening inside. If it's f of x minus h, that's happening inside. So it's happening inside the exponent or inside the logarithm. Okay? So that's why you see the plus or minus up in the exponent. It will also be inside the logarithm. Log of x plus 1, all in parentheses, would be a shift to the left 1 unit. The vertical stretch or compression is going to happen outside, but it's multiplication, right? Outside with multiplication. So if it's 6 times 2 to the x. Now, can I make that 12 to the x? No, that's a really common mistake that happens all the time. The exponent is acting on the base first. You cannot do the multiplication before the exponent, right? Please excuse my dear Aunt Sally, right? Excuse comes before my. So E comes before M. Exponent comes before multiplication. The exponent is acting on it first. You cannot do the multiplication. Like a lot of people would try to tell me that's 1 to the x right there. No, you can't do that. Just like if it's 3 times log of x, right? I know there's something we can do with that. But even if it's like this, can I distribute into the log? No, you cannot distribute into the log. Okay? You cannot like take it log of 3x plus 3. You can't do that. Right? It has to stay on the outside. There are other things that we could do to simplify that, but multiplication, you cannot come in like that. And then horizontal stretches and compression. Remember, that's the funky one where it's the 1 over v, right? So if it's like a stretch by 5, it's going to be 1 over 5. Now, again, it's happening inside the parentheses, so it's going to happen inside the log or inside the exponent. So stretch by 5, horizontal stretch by 5 would be a 1/5 x in the exponent, or a 1/5 x inside the log. Multiplication inside the log or inside the exponent. And then the reflections, negative on the outside is a reflection across the x-axis. Negative on the inside is a reflection across the y-axis. Inside and outside mean inside of the exponent or inside of the log or outside of the exponent and outside of the log. Okay? So they're pretty straightforward. In my opinion, these transformations are a lot easier than the transformations that we had to do with my polynomial functions, right? Think about all the things that we had to do with the polynomials. Like if I took it right 3, and I had to do an x minus 3 raised to the third power or something like that, and I had to FOIL that all out. The difficulty came in the simplification, not actually what we were doing. There's really no simplification to do with a lot of these because we can't. Because they're within or out of exponents, and we can't really do a lot of simplifications. So you know what I want to do here? I just want to graph this in our calculators. Let's see what's going to, let's kind of think about what's going to happen, and then we'll graph it in our calculators. Let's do this. Don't start typing yet. Let's sketch what we think it's going to look like. Let's sketch what we think it's going to look like. So the original, like if I were to graph the original, I guess I should have left my graph up there. If I were to graph the original, 2 to the x, it looks generally like this, where this is at, where is my y-intercept? 1, right? Because if I plug in 0, I get out 1. So there is my 2 to the x. Okay, what do you think happens with 2 to the negative x plus 1? What do you think the plus 1 is doing? Taking it up 1 unit. So a preliminary graph, and I'll erase this in a second, is just going to do this, right? Okay, what's this going to do? It's going to reflect it, right? Okay, so let's go back to our table, figure out which one. It reflects it across the y-axis, okay? So it's going to flip it this way. It's going to flip it horizontally. So that's what I'm going to do. Watch this. Smartboard magic here. Flip, horizontal, left, right. Oh, it didn't keep my y-intercept. That's okay. So it's going to cross like right there, looks like. Okay, now it did go up 1 unit. I gotta keep doing that. There you go. Okay. Hey guys, let me ask you a couple of questions. Where is the asymptote now? It might be a better question to ask, where was the asymptote? For 2 to the x, where was the asymptote? Y equals 0. Okay, so if the asymptote was y equals 0, what did I do to the asymptote? Up 1. So where's the asymptote now? Y equals 1. Does that make sense? Let's graph it in our calculator and make sure that this is happening the way we think it should. Okay, let's start by just doing 2 to the x. We can clear that out if it gets in our way, but let's just start with 2 to the x. And now we're saying 2 to the negative x inside parentheses, I'd like to do, plus 1. Zoom 6. Now, did it do what we think it should have done? Yeah, and now look at my asymptote. Don't I see my asymptote now? Right? So let's kind of extrapolate off this. Let's think about what we can say now about all asymptotes in terms of exponentials. What's the only thing that will shift an asymptote in terms of an exponential? What's the only type of transformation that will change an asymptote? A vertical translation, a vertical shift up or down. That's it. That's the only thing that will move a horizontal line. Like if I move a horizontal line left or right, is that going to change where it is? Not really. If I reflect it this way, left or right, is that going to change it? No. The only other thing that would do anything to it, well, actually, no. If it was originally on the y-axis and then I flip it over, or sorry, the x-axis, I flip it over the x-axis, it's still on the x-axis. The only time it would ever change again is like, say, I had, there's the asymptote at y equals 1, right? What if I reflected that over the x-axis? Then it would jump down. right, to -1. That's the only other time anything else other than a vertical shift would change the asymptote. Okay, that's an important thing to know. The only time you would ever change an asymptote for an exponential is a vertical shift. Okay? Okay, graph the function, find the y-intercept and the asymptote, and describe how the graph is transformed from the graph of its parent. Let's first say this. What type of transformation happened in this one? Before we touch our calculators, what type of transformation is happening? By how much? 2/3. So what would it be? Stretch or compression? So it's a vertical compression by 2/3. Oh, shoot. Oh, jeez.
Exposed.
Oh, it's Mr. Casson. Somebody remind me to take 10 seconds. I'm Mr. Casson. Yeah, what's up? GeoGuessr.
GeoGuessr.
With no E.
GeoGuessr's fun.
Right.
Except the only good maps.
And there goes your whole day. You will spend your entire day doing that.
That's completely true.
It really does.
It places you
And place it,
They're loving
so you place your mail place on Google Earth, and that's where it's at.
All right.
I'm gonna.
I did it.
Got him.
Yeah,
You
play
guys
it
know
on,
what that is?
yeah, play it on
Oh,
screen.
yeah.
No, not on video right now.
Wait, what's it called?
GeoGuessr.
Um,
Awful. But all the good maps cost money. Like, you might get a good map, like, oh, it costs money.
I know they monetized all that stuff like not too long ago.
Like, I'm gonna do like the cool maps of like places in the US. No, I don't think it's just the
cut it out of the video.
I can edit it out. Who's not here?
No.
Yeah.
Now the whole knows who I
This,
am.
yeah.
I thought I saw
Emily.
Who?
Emily.
Emily, shut up. Anybody else?
Gavin, I miss you.
I got Gavin, right?
Rest in peace, Gavin.
Gavin, if you're hearing this, I guess everybody else too, Emily and Esther. If you're hearing this, we miss you.
Don't get the coronavirus.
He's already got it.
We don't miss you, Evan.
Gavin, we missed you.
Okay, so this is a vertical compression by 2/3. Now,
Definitely.
let me ask you this. What's going on with the 1.5? It's just there. That's just the base. Does anything ever change what the base is? No. So think about this. What was my parent then? 1.5 to the x. You know what the parent is based off of what your new is. The base will never change. The base will never change. So vertical compression by 2/3. So let's graph this in our calculators, knowing that this is going to be a vertical compression that's going to compress down toward the x-axis by 2/3, by a factor of 2/3. So here's my parent, 1.5 to the x. Here's my new, 2/3 of 1.5 to the x. So there's my original, and here's my new. Did it compress down toward the x-axis? Yes. Okay, so here's my graph. So graph the function, check, find the y-intercept. What's the y-intercept now? Is it still at 1? 2/3, right? It's at 2/3. If I plug in 0, this would be 2/3 of 1.5 to the 0, right? 1.5 to the 0 still goes to 1, but now it's just 2/3 times 1, or 2/3. So the y-intercept is 0, 2/3. Now, where is the asymptote? It's still at y equals 0. Now, I'm going to be really picky. I want you to tell me y equals 0. Don't just say 0. Because when we change to logarithms, it's going to turn into x equals 0. Right? Okay. So we found the intercept. We had the asymptote. We described what the transformation was. I think we did everything there. Let's do another one. Get this out of the way. Okay, go ahead and try this on your own. With the asymptote, put it in your calculator, sketch the graph, describe what transformation happened. Also state the y-intercept as well.
We should have live streamed this just for Gavin.
It's 11. So live stream.
Live stream.
Communism manifesto. That's not what it's called. It's called.
Isn't this common sense?
Yeah, it is, but you gotta say the full word.
What?
It's gotta be fancy.
I wonder which Gavin.
Oh. Isn't it just?
You know, actually, this one is a little interesting. Because what do we think is going to happen? What's the negative? Over. Reflect over the y.
Yeah.
And then the plus one should be doing what? Left one, right? But what order? Do I reflect it, then move it left? Or do I move it left, then reflect it? Let's see what happened. Let's see what's going on. Now, what's my parent? E to the x. Okay, so now this is e to the negative x plus 1. Okay. So there's my original.
There it is.
What about the cheese?
Oh, yeah.
The streak is dead.
Yes, no more jokes.
So back to math. What happened here? I know, really. I feel like it should have been more than
She's holding it, that's one.
That's just
Yeah,
one period
once
of
it get
data.
recorded, but it's different, like.
It looks like it got reflected, then moved right one, didn't it?
That's weird.
Or it actually moved left one, then reflected. Why is that happening? Because couldn't I rewrite this? Couldn't I say this? What if I pulled out a negative?
Scary.
Now it's reflect, then move right. Don't we see that?
Yeah.
So it's either reflect, then move right, or move left, then reflect. Weird. Right? Weird. Okay? Because they end up being the same thing. So here's my graph. Now, at any rate, what's my y-intercept here? 0, comma what? If I plugged in 0 for x, e to the negative 0 plus 1. What's negative 0 plus 1? 1. So my intercept is 0, comma, e. Oh. Oh. How did I do that one more time? Okay, if I plug in 0 in for x here, right? This would just give me e to the negative 0 plus 1. Well, what is negative 0 plus 1? Just 1, right? So this ends up just being e to the first. So 0, comma, e. Right? Remember, that's just a number, right? 0, comma, 2.718, right? Is that still my intercept? Yeah, it looks like it. All right, now, let's say, where's my asymptote? Did it change? No. So the asymptote is still y equals 0.
Yeah. Is it always going to be y equals 0?
No.
To be x.
Because what happened here, right? We translated it up 1 unit, so the asymptote went up 1 unit. So we'd say y equals 1.
Oh, okay.
Yeah.
So if we don't mess with the asymptote, then all the way to 0, but
Yeah.
if we mess with the
Yeah. He brings up a great point. So if you mess with the if you don't mess with the asymptote, it's always just y equals 0.
Okay.
But then if you do any sort of vertical transformation to it, then it changes. Okay. Now, because a log is an exponent, the transformations of logarithms are very, very, very similar, right? This again is that same table. Look at the examples now. Happening outside is happening outside. Happening inside is happening inside the log. Happening outside is happening outside the log. Multiplying inside is multiplying inside the log. Negative outside is negative outside the log. Negative inside is negative inside the log. Okay? It means all of these things are very, very, very similar to what we had done with exponents. Okay? Because exponents are logarithms. So, graph each logarithm function, find the asymptote, describe how the graph is transformed from the graph of its parent. Did you just throw your calculator on the floor? Calculator abuse is a problem.
It's a real problem.
It's a real problem. All right, graph each logarithm function, find the asymptote, describe how the graph is transformed. Okay, so what do we think is happening here?
Vertical stretch of 5.
Good, and?
Going vertical visualization down to.
Good. So we have a vertical stretch of 5, vertical stretch 5, and a down 2.
I know it.
There you go. Let's go. Okay, so now let me ask you this. What is my parent? Log x. What's my base on that? 10, right? Common log. I will always give you either log base 10 or log base e, because that's the only thing that my calculator can graph. You guys can do a little bit more, but that's the only type of graph I can do. So we have log of x, there's my parent. And then 5 log x parentheses minus 2. Okay, there's my original.
Do you have to put the parentheses around the base?
It just does it. You have to cap your parentheses. You have to end it.
Yeah.
Because if you don't end it, then it's going to assume that it's going to go inside parentheses, which is right too. Right? So there's my graph. Okay, now we talked about it a second ago, but what was my asymptote? What was my asymptote? X equals 0. What's my new asymptote? X equals 0. Did I change it at all? No. You know what people always think? That it's somewhere up here. It's not. It doesn't have a horizontal asymptote. It has a vertical asymptote. It's the inverse of an exponential. The exponential has a horizontal asymptote. The logarithmic has the vertical asymptote, which means x equals 0. Okay? So graph the log, find the asymptote, describe the transformation. Done, all 3. Okay? You right over there?
No, Wendy, it only gets worse.
Look at that chart.
Okay, Kevin does the
So excited.
Log base e.
Yeah,
No, Gavin's not scared.
but Gavin's chart is like this.
It's
Like
just a straight line.
Yeah, literally that's how it is.
That is What?
okay,
Mine
so
is
h of
down.
x is ln of negative x plus 2. What's right?
Can't be on.
I know it's probably gonna like go down. You know? There you go. Ln of negative x plus 2. Okay, so what do I see here? What type of transformations do I see? Left 2 and reflection over the
Well,
reflection over
what's the weird thing?
y and left, and I'm actually going to put that ahead of it. Yeah, because guess what could happen for this one as well?
Take the thing out. And then just give me x minus 2. Yucky.
I believe so. Let me just make sure. Okay. Natural log of x is my original. My new is natural log of. Oops. What? Oh man. ln of x. My new is ln of negative x plus 2. Okay, so there's my original.
Whoa.
Good. Now,
Wait.
it looks like it stops, doesn't it?
But keep going.
It keeps going. Remember, your calculator is a very dumb, smart object. Come on, get back to me.
Let's go. So
Right? Your calculator does not show, it thinks it stops, but it doesn't. Your calculator does not show that it dives down right there. Right? Okay, so it either goes left 2, then reflect, or it goes reflect, then right 2. Okay? No matter what, this is my new, where does my asymptote end up? 2. Give me the full equation though. X equals 2. There's the asymptote. Because it was at x equals 0. So think about this. What was the only thing that changed an exponential asymptote? A vertical shift. What's the only thing that's going to change a logarithmic asymptote? A horizontal shift.
Whoa.
Like this. Okay? Right, and that's why this will change it as well. If I went left 2, that's going to change it, and then it's going to change it again after I reflect. That's why it ends up at positive 2, not negative 2. Yeah. That's fun right there. That's so cool. All right, write the equation. 4 to the x is reflected across both axes, then moves down 2 units.
Wow, this student's cheating.
Wait, you telling me like wait, so it
Go in order of the question too. Reflected across both axes, then move it down 2 units.
Do you reflect over the y? Is that the x or the or
Doesn't
the
matter.
x and y?
They're independent. It would matter if I went down first and then reflected.
and then negative. I don't know.
Okay,
That was right.
so reflected across both axes is that, right? Okay, what's 2 units down?
Oh, cool.
Okay, that's right.
Right? You okay with that?
Alright.
-2 goes to x up to x.
Yeah. So, question up here was, if it's a horizontal shift, the -2 goes, and actually would turn it, it depends on whether I go left or right. The plus or -2 would end up going up in the exponent, right? That's horizontal. Right, and then last one here. Ln of x is compressed horizontally by a factor of 1/2 and move 3 units to the left. Go in order.
Oh.
It would change if I went left 3 and then horizontally compressed. What's going to happen to my 1/2? It's going to turn into a 2. And then inside the parentheses, it's going to move to the left 3. Now, watch here. This is important, everybody. This is halfway there, right? I have not done my left 3. Watch this. Here we go. Now, g of x is going to turn into ln of.
I didn't do that.
You have to have that parenthesis in there. Here's why. Hold on. Here's why. Because the transformation changes the x value, correct? So if I'm doing that afterward, I have to remove x and in its place write x plus 1. So I am going to take away x and in its place I have to write x plus 1. Because that's the transformation. Going left. Oh, I'm sorry. Sorry, hold on. I just got the wrong number. Relax.
Oh.
Relax. I just did the wrong number.
This is new to us, we come here so often.
Sorry. You guys are all like, wait. But we could simplify this a little bit, right? Just distribute the 2, ln of 2x plus 6. You guys are looking at me like I had 5 heads. You're like, whoa. Where'd the 1 come from? It came from my brain right there.
It's just cause it's there.
Hey, I'm sorry, but it's after 8.
It is after 8. There's no excuses. No excuses at all. Bye, everybody.
I love you, Gavin.